Okay, this is a bit of a review for exam number 2. I apologize for the noise in the background. My son's watching Star Wars, so enjoy the lightsaber fight. What I want to do is stress that you look over these topics to make sure you understand them. And all of these topics here, this is the handout I gave you in class. All these topics are covered in homework 4, 5, and 6. I also wanted to discuss a little bit about homework number 6 to make sure you understood all those key ideas. I did go through it kind of rapidly in class, so I want to do it a little bit more carefully right now. For these, we did these in class, but if you missed that, the answers to these questions are located in sections 17 through 31 in this textbook here. That was my son. Alright, and so recall that lowercase a is altitude and capital A is azimuth. You can find the answer to this question in section 18 of this textbook, and section 19 for this one, section 21, section 22, and down here just use your star chart to find local sidereal time. So directly off of the star chart for these, we did an example in class. To figure out the hour angle when an object is directly on the meridian, meridian is a line from north to south through the zenith, you can look at figure 6. And figure 6 looks like dramatic music, that right there. So here's our angle. So what if it was on the meridian? What would it be? Let's say, why don't we include units for this one and make sure that it's in hours, because it is our angle. Alright, so number 9, the diagram that will help you for this one looks like this, our familiar problem. This is a north celestial pole. If a star is right there, its declination is 0. If a star is on the celestial equator, it's 0 degrees. So that's the celestial equator. Recall that Canopus is that star we see just above the south horizon, above Walmart, in the glow of Walmart, and so it's going to be a few degrees up. I'm going to leave it to you determined where it's at. And what you do is you draw a line through Canopus, because it says it's on your meridian, and that will tell you what date that occurs on. I think we already touched on that a bit. Right ascension and declination can be obtained from the star chart, and for these two I want you to get it right off of this by looking at basically the angle above the horizon, and then use the definition of azimuth, which is an angle from north toward the east, to figure out what the azimuth of Canopus is on that day. Local sidereal time can also be found from the date on your star chart, not from the... You could do the calculations, but let's keep it simple using star charts. I guess that means I'm going to have to provide some star charts for the exam, of course. For H, you could see problem 8 or see section 24 for this one. Because it's on the meridian, you can use problem 8. Now down here, you can't use problem 8 to find our angle, because the star is not on the meridian. So I want to make that clear on this one, that Sirius is not necessarily on the meridian this time. We're going to find out that, it's maybe over here somewhere off on the celestial sphere. I'm not exactly sure where. And what will happen is you'll have an altitude A and then an azimuth like this, capital A. So you measure from north around, and then you measure from horizon up to get altitude. So there's lowercase a, and here's capital A, which is measured around like that. I don't want you to make those measurements from this graph, or this diagram. Rather, I want you to use the equations from section 25. So from the star chart, get these three, and then use section 24 for this one. It basically involves a simple calculation between those two things there to figure out what this is. Pay attention to sign, whether it's a positive or negative value. You can use the observatory website to get an answer right there, and make sure that you use 5 digits for these, like that, to the right of your decimal. It does, I guess we'll have to have these in hours and hours and hours, but the other ones will have to be in degrees. And for the last part, this is where section 25 comes into play. Make sure that your calculator is in degree mode, and then you're going to find out what A is here and capital A is there. Can you all hear Yoda in the background? Make sure that when you do these calculations that H is in degrees, and also think there's all the other ones are in degrees automatically, but H will not be in degrees right there. But you want to you might just convert it over to degrees, because your calculator only works in radian or degree mode. So all of these things need to be in degrees. I wanted to point that out, and that's exactly why on page 1 we had this problem here where you're converting from hours over to decimal degrees. This is why we have these kind of example problems, because in order to do these involved calculations with sines and cosine, everything has to be in degrees. Of course, it gives you an example to work down here so you can see exactly how they plop this in the correct quadrant. Okay, sorry about that. My son has just informed me that the Ewoks are on the way. On problem number 11, you have Venus at this date. You want to use stars and planets from that right there. Yes, Venus. That's the one we're doing. Make sure you record these answers in 5 digits to the right of the decimal place. So I'm going to verify all of that. I guess you really can't do it for this one here. Probably three digits on that one. If it's on the ecliptic, you just kind of look at the definition of what galactic, ecliptic latitude, that's ecliptic longitude. Obliquity, that was covered on the first page. You can use practical astronomy, page section 27. Oh, that's right. So you really can't look on the star chart to find right ascension and declination. Instead, what you have to do is a coordinate transformation. And that involves this one right here. You bumped your head. You okay? Okay, be careful over there, bud. Alright, so then take the inverse tangent to find this. Everything is in degrees here. Everything is in degrees right there. And be careful about quadrant. Maybe not. I don't think you have to worry about quadrant on delta, because the inverse sign will always give you a number between minus 90 and positive 90. And that is actually the range of values for declination. So that's okay. But on the alpha, you'll have to do 2 things. One of them is make sure that the inverse tangent is in the right quadrant, and also convert it to hours after the fact. Remember that 15 degrees corresponds to 1 hour. All of that is covered in this example problem over here. So if you get stuck on figuring out what quadrant it belongs to, refer to this figure and that example, and that will help you put it in the right quadrant. Make sure you know how to do this before the exam. That's kind of the tricky part of getting the right ascension in hours right here. 5 digits. Alright, star chart here, and use this one and that one to find hour angle, and then go back to section 25 right there to find A and capital A. Make sure that's in degrees. When you get an answer right there, make sure you put it in degrees. On the back side, we already said that at the galactic center, it's 0 degrees and 0 degrees. That makes it kind of easy. So what we're doing is figuring out what the coordinates are for the center of the galaxy. And the center of the galaxy is far, far away, like that Star Wars reference. Alright, so here's section 30. You're finding alpha and delta, the right ascension and declination of the center of the galaxy. You'll be able to tell what part of the star chart it's in. As a hint, just for watching this video this long, it is near the constellation of Sagittarius. So that should... Oh, wait a minute. That's one of the answers. Okay, so you get a free answer right there. Nice. Alright, make sure you do this inverse tangent. Put it in the right quadrant, as they show right there. Make sure it's in hours, minutes, and seconds. No, just put it in hours with 5 digits over there. Hope this helps. See you soon.